Capacitor has three important characteristics. These are the capacitance, the tolerance, and the working voltage, as they are printed on every capacitor's body. Capacitance is an electrical amount of capacitor rated in farad as the largest unit, followed by microfarad, nanofarad, and picofarad. This type of capacitor, an electrolytic aluminum capacitor, has a capacitance of 2,200 microfarad. For all types of electrolytic capacitors are marked in microfarad already. So, unlike this type of capacitor and the rest of the capacitors here, except electrolytic capacitors, that the value is in numerical code. For example, it is printed here 185J. 185 actually is not the final capacitance. So we need to compute that. So we have here 185J. The last digit here indicates the number of zeros. So just rewrite 18 plus 5 zeros. So that is 1,800,000 picofarad. So we need to convert that into microfarad to lessen the number of digits. So we have here, from picofarad, we have to move the decimal point to the left 6 places. For pico has a scientific value of 10 raised to the power of negative 12, whereas micro has a scientific value of 10 raised to the power of negative 6. So the gap between them is 6. So, move the decimal point to the left 6 places. 1, 2, 3, 4, 5, 6 to make it 1.8 microfarad. So, 1.8 microfarad is actually the capacitance of this capacitor. We can actually measure the capacitances of capacitors using the multimeters. This analog multimeter, Sanwa brand, is equipped with capacitance meter. We have here, just set this to times 100K. It is also actually the microfarad meter. Then we have here the C microfarad, the black meter scale here. If you have a Sanwa brand, it is actually equipped with capacitance meter. But the highest capacitance that can be measured here is only 10 microfarad. No? When you connect the two leads or the two tips of this rod, usually the pointer deflects. So, your eyes must be clever enough to watch the stoppage of the pointer. Actually, the pointer stops over here. It is at 1.8 microfarad. It goes like this. See? So, it will be very hard for us to use analog multimeter compared to digital multimeter. Okay? Set this to the yellow color here for ohmmeter, diode tester, and capacitance meter. So, select. We are now at mega ohms. Then volt for diode testing. Then we have here the ohms again. And the nanofarad, the unit for capacitance. So, we have here, just connect the two test rods here to the two terminals of this capacitor. It is 1.805 microfarad. That is now the capacitance using the capacitance meter of this digital multimeter. So, the measured value actually is, you have here, is 1.805 microfarad. This 1.8 microfarad is based from the printed numerical code of the capacitor. Based from the numerical code. But this one is the actual value, the measured value. Here comes now the tolerance. Because J here indicates the tolerance. We have the JKM. J is more or less 5%. K is more or less 10%. And M is more or less 20%. The given tolerance here is J. Tolerance, by the way, is the minimum and the maximum allowable capacitance of a capacitor. Okay. This is to determine also if the capacitor is still good or bad by computing the tolerance. Okay? So, here, let us compute 1.8. The numerical code, based from the numerical code, is 1.8 microfarad times the tolerance given is more or less 5%. When we convert that one to decimal value, that becomes 0.05. So this is 0.05. So 44, 9. 1, 2, 3. It is 0.09 microfarad. That is the product of multiplying 1.8 microfarad and the tolerance 0.05. So, to get the more, 1.8 as the numerical code value plus 0.09 to get the more is 1.89. So that is 1.89 microfarad as the maximum tolerable capacitance. And to get the less, 1.8 microfarad minus 0.09 is 1.71 microfarad. That is now the maximum tolerable capacitance and the minimum tolerable capacitance from the numerical value given as it is printed on the body of that capacitor is 1.8 microfarad. We have here now the measured value. What was the measured value? That was 1.805 microfarad. So, 1.805 microfarad actually is the measured value. And the capacitor is said to be good, as the measured value is 1.805 is still within the tolerance limit. It is not above 1.89. So we can conclude that this capacitor is still good when we compare the measured value to the given value. No? Okay. Then, there is also there the working voltage, for example, of this capacitor, 50 volts. Working voltage there actually is the dielectric strength of the capacitor. Dielectric strength is the ability of this capacitor to withstand the applied voltage without exploding. Okay, without exploding. Meaning to say that the maximum voltage that can be applied here is up to 50 volts only. If it exceeds the 50 volts, so this capacitor will explode. Okay, let us try to have this capacitor. This capacitor has a working voltage of the working voltage here is only 10 volts. The capacitance is 100 microfarad. Okay. Let us set this to okay. We have here 185. Where is the capacitor? Okay. The positive side is connected to the positive of the capacitor with respect to the negative of the capacitor also here. Okay. The capacitor now is charging or storing voltage based from the power supply here. The voltage supplied is 8.5 volts. Okay, let us measure if there is 8.5 volts here. We'll set this to DC voltmeter. We are now at DC voltmeter. So the voltage here is
Oh, the applied voltage is only 7.5. No? Because it will take several seconds before the voltage is totally filled, equal to the applied voltage. Okay. However, if the voltage applied here is exceeded, let us say we will set this to 31 volts. Then, positive here and negative here. Okay? The maximum voltage that could be applied here is only 10 volts. That is now the dielectric strength. But if the voltage applied is exceeding the working voltage here, the result will be like this. See? That is now the result. When the applied voltage exceeded the working voltage of a capacitor. Okay? The maximum voltage here is only 10 volts. Meaning to say that the voltage that can be stored here for this capacitor is only 10 volts. But the applied voltage is over the value of the working voltage. Okay, that is how important is the working voltage. Okay?